Guys, today I want to explain a very interesting question from the AB Calculus AB FRQ 2025, free response number 1. So this question is basically saying that we have this function ct equals to 7.6 arctan 0.2t, and then we're supposed to find and we know the derivative is c prime of t 38 over 25 plus t squared. So for a we're supposed to find the average number of acres affected by the number of species. So whenever you see average number and we see a range from, for example, here we have 2 to 0 and t equals to 6. So when we have a range and we have an average number, we think about the average value thing. So this is about this. So it's 1 over b minus a, and antiderivative of b to a fx dx. So this is the theorem that we're supposed to use for the first one. So right here we see to find the average value of the function over an interval a/b, closed interval a/b, we use the formula 1 over b minus a, the integral of b to a ft dt. So the setup here is basically, now we have 1 over 4 minus 0, from 4 to 0, 7.6 arctan of 0.2 t dt if we plug everything in from the question, right? So this is about equaling to 2.41 acres, and that's how easy the first question is. For B, we have find the time interval of the instantaneous rate change, so instantaneous rate change of c, and the average rate change of c over the time 0% smaller than t smaller than 4. So for this one, we also use the mean value theorem. So for the average rate change, we have mean value theorem right here. We have the setup would be c4 minus c0 over 4 minus 0, and this should result in the answer 1.281 acres per week. Okay, remember to write the units down. And then for the instantaneous value, we know that the c prime of t equals to 38 over 25 plus t squared, which is 1.281. And then so if we solve for t, we know that t will equal to 2.159 weeks. Okay, so that's basically this question. For C, it asks for the derivative c prime of t as it approaches infinity. So limit of t approaches infinity, c prime of t equals to t. Limit of t approaches infinity is 38 over 25 plus t squared. So as t becomes infinitely large, the denominator of 25 plus t squared also becomes infinitely large. A constant divided by infinity approaches 0. So in this case, limit of t as it approaches infinity, c prime of t equals to 0. So for part D, we're supposed to find the maximum value. So we are looking for the maximum value of AT on the interval 4 to 36. To find this, we check the endpoints and where the derivative a prime of t equals to 0. So using the fundamental theorem of calculus, so you should know the fundamental theorem of calculus, we get that a prime of t equals to c prime of t minus 0.1 ln t, which equals to 38 25 plus t squared, 25 plus t squared, and minus 0.1 ln t. So this will be able to equal to t. We should find that t equals to 11.089. So yes, so we know that t equals to 0.89 weeks, and that's our answer. So for justification, we can say, okay, so A4 equals to C4 equals to 5.125, justified. A 11.089 equals to 6.314, this is the max, it's justified. And A36 equals to 4.095. So this is our answer.